Good afternoon, everyone, and welcome to another edition of Science with Mama J. It's good to see you again. So, today we're going to be doing a series of chemical reactions and exploring what some of those reactions mean. So, we're going to jump right into it. This is activity 4B. So, it's indicators of chemical reactions. So, as you can see, I'm wearing protective gloves because some chemicals are a little bit more dangerous than others, and we want to stay protected. So, I have done some prep work in the beginning to avoid wasting time with measuring and things like that. So, hopefully, we'll be able to run through this pretty smoothly. So, our first experiment, we're going to be looking at what is called a change in color or hydration. So, what I have here is measured out 5 grams of copper 2 sulfate, which I'm going to go ahead and put in a clean, dry test tube. Okay, you'll notice that I kept it covered. Okay, and our initial observation of this particular chemical is that it is white. Okay, so we're going to go ahead and add about 25 milliliters of water and mix that. And as you can see, it has turned blue. Okay. It's also actually gotten a little bit warm. All right. There's a definite change in temperature of the glass. So it's a couple of things to observe. Number one, as we mix the chemical, and it's definitely hotter at the bottom. Okay. As we mix it. And then on top of that, we've got, and since I won't be needing this anymore, I'm going to go ahead and stir it. Okay, it's definitely warming up a tad bit. Okay, so it is a slight exothermic reaction. And what that means is it is actually releasing some heat. It's why it feels hot to me. So, but the main thing that we want to observe here is that this particular reaction, it turns blue. Okay, so that is a color change reaction. So this is basically used to identify the presence of water. Okay, copper 2 sulfate in the presence of water turns blue, as you can see. Okay, when it has absolutely no water in it, it turns white. Okay, so our next reaction is change in color, acid and base reaction. So what I've done here is I put about 2 milliliters of vinegar in a test tube. And I'm going to go ahead and I'm going to put a few drops of phenolphthalein. Okay, phenolphthalein is an indicator. So 1, 2, 3. Okay. Phenolphthalein is an indicator, and as you can see, it is still clear. So then what we're going to do is we're going to slowly add 1 milliliter of sodium hydroxide to the solution. Okay, so sodium hydroxide is a base, and as you know, vinegar is an acid. So, and sodium hydroxide you need to be very careful with because as it is, it's a very strong base and it's a corrosive. So we're going to do one at a time. You may or may not be able to notice a little bit of pink as I do this. And you want to continue to do this. Let me switch hands so you can see better. You want to continue to do this until the color persists. And of course you want to shake it between each one to make sure that it is completely mixed. And there we have a persisting pink color. So now we do have a little bit of sodium hydroxide that slipped here, so I'm going to go ahead and kind of neutralize it with some vinegar and wipe it off the table, and we can go ahead and clean that up a little bit later, but it was neutralized. So now basically what's happened here is that I added a base to an acid, neutralizing the acid. The acid is full of hydrogen ions, okay, H plus, and the base itself, is OH minus. Okay, so it's got what are called hydroxyl ions. So when we added the base to the acid, we persistently neutralized the acid. So what this indicator is showing us is that we no longer have any hydrogen ions present. It's been completely neutralized and there are no longer any hydrogen ions present in the system. Okay, so we've used up all of the hydrogen ions and they've bonded with the hydroxide ions to form water. So now what we're going to do is we're going to see what happens when we introduce an acid, and this is just basic household vinegar. What happens when we introduce an acid back into the system? And just a drop or two of acid and you can see that it has turned clear again. Okay, so now the next thing that we're going to do is we're going to do a reaction that may need some time to occur. So we're going to do the reaction now and we're going to leave it for a moment while we do another one and give it an opportunity to occur. So we're going to put 10 milliliters of water in a test tube, which I've already done. And in that test tube, I'm going to add 1.5 milliliters of vitamin C. Okay. 1.5 milliliters of vitamin C. And then we're going to add 4 milliliters of iodine tincture. Okay, so okay. Go ahead and give that little bit of a whirl. All right, now prepare a 1% starch solution, which I have here. Okay. So in my second test tube, I have 20 milliliters of water. And I'm going to add 4 milliliters of hydrogen peroxide, which I have measured here. And 4 milliliters of the starch solution. Okay. Now, I'm actually going to put both of these. We're going to pour the contents of the second test tube into the first test tube. So what I'm going to do is, because obviously neither test tube is big enough to accommodate that, I'm going to take the first test tube and I'm going to pour it in here. And I'm going to take the second test tube and pour it into the contents of the first test tube. And I don't know how well you can see this, but it has turned just about black. So we're gonna let that sit for a moment. As we said, this particular reaction may need some time to occur. So we're gonna let that sit for a moment, and that while that's sitting, we're gonna move on to the next thing. Okay, so, but we do notice a distinct color change here. Okay, so for the third one, we're gonna pour 10 milliliters for the next experiment, excuse me, the fourth one. And I'm gonna go ahead and actually move these, since we're done with it, and bring the next set of test tubes. Okay, and I've got 10 milliliters of water already placed in the test tube. So we're gonna add 20 drops of silver nitrate. Okay, where's my silver nitrate? Here we go. We're gonna add 20 drops of silver nitrate. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, and then we're gonna add sodium hydroxide drop by drop. So right now we're looking at silver nitrate. As you can see, it's a little bit cloudy, clearish cloudy. And I'm gonna take some sodium hydroxide once again. And we're gonna add it drop by drop. Okay, so immediately with the first drop, I'm noticing it turned a cloudy tannish color. And it's getting darker as I add each drop. So I've now added 3 or 4 drops at this point. Okay, and it has become a brownish color. I'll add 1 more drop here. Okay. And what I'm noticing as I allow it to settle, and we'll give it some time to settle a little bit more, but there seems to be a collection occurring at the bottom. So we're gonna let that sit for a moment. We're gonna let this sit for a moment and see what happens. Okay, and we have 20 milliliters of water that we're placing in this particular test tube. Okay, and we're gonna measure the temperature of the water. So before we do anything else, we have to measure the temperature of this water. So according to this, the water is 22 degrees Celsius. So what we're going to do now is we're going to add 4 pellets of sodium hydroxide. There we go. And while we add the 4 pellets of sodium hydroxide, we'll go ahead and shake it up. Give it an opportunity to dissolve. Now again, sodium hydroxide. Okay, you can kind of see a reaction happening here. Sodium hydroxide is the same as what's in here. It is a base, but this one is in a solid form. And using a temperature probe, just stirring with the temperature probe, I've so far gone from 22 degrees to 29 degrees, 30 degrees. So I've had a sharp increase in temperature just by putting sodium hydroxide in the water. So sodium hydroxide in water, it is an exothermic reaction. It releases thermal energy. I've actually gone up as high as 34 degrees. So 35 degrees, 36. So I peaked at 36 degrees and it's starting to go back down again. So it is an exothermic reaction releasing thermal energy. Okay, so the temperature went from 22 degrees to 36 degrees. Okay, the last experiment that we're going to do is gas formation. So we have about 20 milliliters of hydrogen peroxide in here, and we're going to add a little bit of iron powder, and we're going to observe what happens. Not a lot, just a little bit. I'm going to give that a second to react and watch and see what happens. Can actually take the back end of this rod and stir. And we'll let that sit for a moment while the reaction triggers. Oh, we can actually start to see the bubbles are really small. I may need to add a little bit more iron in here. It's starting to trigger. Just need to give it a moment to react. So let's look at the other two experiments that we've had. So this particular one, it has turned a dark liquid. I'm going to see if anything else has formed in the bottom. So it has formed a dark black liquid. From a pale clear brown solution, it has formed an opaque liquid. And the other one, it's very hard to see, but there is actually a muddy brown solid that is at the bottom of this. Let me go ahead and clean this off, and I'll scoop some of it out so you can actually see. There's actually a brown solid precipitate at the bottom. You can probably see it as I stir it a little bit, and you can see some of it here. So it's a solid that is coalescing at the bottom. And you may be able to see that now. It's taking a little bit of time, but it will eventually turn clear with the brown solid at the bottom. And now our last reaction, you can actually see it more now. It is a gas formation reaction. So the hydrogen peroxide is reacting with the iron to produce a gas, and you should be able to see that. Okay, so it is producing a gas. When I shake it, you can see the gas production a little bit more, but it is producing a gas. So, to recap what we have, okay, the very first reaction we had was the copper sulfate. When it was added to water, it went from white to a very pretty blue. And then we had, and that was indicative of a hydration reaction. And then we had the pH reaction where we saw an acid was neutralized by a base, and that was indicative of it turning pink. And when we added the acid again, it turned clear again. Okay, the next reaction we had was when we put two substances that were clear in nature. The liquid was clear, a clear brown and a clear liquid, and when it was combined, it turned to this very deep opaque liquid, almost, it's a brownish black. And then our fourth reaction was a precipitate. So what we saw here is this substance when we added to silver nitrate, when we added sodium hydroxide, it formed it. Now you could probably see it very clearly, a solid at the base, okay, that's precipitating out of solution. So what a precipitate basically does is it is a solid that falls out of solution. Okay, it can't be supported anymore in the solution, so it falls out of solution either due to density or there's just no more space to hold it. Okay, and then the next reaction was the temperature change. That was the sodium hydroxide. As it mixed with water, it underwent a temperature change where it released thermal energy. It is an exothermic reaction, and that is indicative because the outside of it feels hot. It gives off energy, and the test tube actually gets hot in your hand. The opposite of that, which is an endothermic reaction, is if a reaction actually feels cold. So the test tube in your hand would get colder. And then you have the last one, which is the gas formation reaction. And it is actually still producing gas bubbles. It is the iron and the hydrogen peroxide. It's still producing some gas bubbles there. So that's all we have for today. These are the reactions that we were talking about. I hope this was helpful to you, and feel free to drop me a comment if you have any questions, and I look forward to hearing from you. Take care and have a fabulous weekend. Bye.